Welcome to video 3.3 Bravo, Cpctc. This is the crux of the whole lesson. Okay? So I'm going to start out by reviewing a previous definition. If triangles are congruent, then all 6 corresponding parts are congruent, the 3 sides and the 3 angles. We could state that another way. Corresponding parts of congruent angles are congruent. So let me just show you what I'm doing with that. That's a C, that's a P, that's a C. Had I spelled this word out, that would have been a T, and then had I spelled that out, that would have been the C. Oh, so we will abbreviate it in our proofs as Cpctc. Cpctc. Corresponding parts of congruent triangles are congruent. Okay, I've got 2 big notes here. When we're using Cpctc, we will always first get the triangles congruent. First, get triangles congruent. And then once we get the triangles congruent, then we'll get the parts. Next, get the corresponding parts congruent. Once again, you cannot use Cpctc until you first have established that triangles are congruent. That's why we did lesson 3.2 before we're doing lesson 3.3. All right, so here's just a basic application of it. All right, so given this figure here, with SM congruent to PM, I like to mark up my diagrams. SM to PM. MW bisects angle SMP. So if I'm bisecting an angle, I'm going to get 2 congruent angles, not 2 congruent segments. So I'll end up getting that to be congruent to that. Prove that SW, this chunk here, I'll write it up here so you can see it better, is congruent to WP, that chunk there. Common mistake students might jump right to and say, oh, if I'm a bisector, I got 2 congruent segments, but that's an angle bisector. All right, so what I'm looking for is parts of triangles to be congruent. So let me first get the 2 triangles congruent, and then I can get the corresponding parts. That's the whole crux, once again, of Cpctc. So now let's see if I can get the triangles congruent. There's 3 things needed. I've got 2. Reflexive. I'll be able to get MW of the left triangle congruent to MW of the right, the triangle on the right side. And the 2 triangles will be congruent by SAS. And then once I get the triangles congruent, then I'm going to get the parts congruent. That's the strategy. All right, so let's write it out. So step 1, and again, to get the triangles congruent, I like to go into SAS order. I'll start with what was given here. So SM is congruent to PM, given. That was a side. Then I'll just go with the angle. So step 2, MW bisects angle SMP. That was given. From that, I can get the angles. 3, angle, have to use 3 letters, SMW, congruent to angle PMW. And that would be if a segment bisects an angle, then 2 congruent angles, not segments. So if segment bisects angle, then 2 congruent angles. So I've established the A in SAS. And then finally I'll get MW to be congruent to MW. Reflexive property. Then I will get the triangles and then the parts. All right, so step 5. Hopefully I can have room here. So I'll call it triangle, I'll go SMW. Once I have those letterings, I've got to be corresponding. So SMW corresponds to PMW. And my reason would be SAS. And once I get the triangles, then I can get all 6 parts. Which parts do I care about? SW to WP. Let me show you how that's going to work. First 2 letters to first 2 corresponding letters. All right, I'll try to squeeze this in. So 6, hopefully you can see it. SW is congruent to WP, Cpctc. So there you have it, what CPCT is and how to use it in a basic proof.